Okay, so in this part of the lesson, we're just going to deal with four-term polynomials. Doesn't mean that that's the only kind. Now, maybe in your homework you're going to do. You might still do some of the others. I don't remember what I've assigned here, actually, but for sure, tomorrow, you'll be doing a combination of both. You'll have to be able to GCF the 2- and 3-term ones, and then you'll also have to be able to factor the 4-term one, and we actually use the GCF to do that. So when there is a 4-term polynomial, it says, this is kind of important right here where it says try to. In other words, didn't we have a problem in the assignment today that could not be GCF'd? It could not be factored, right? Every polynomial is not factorable. So when it says try to, you're going to see if it can be. So, and what we're going to do if we have a 4-term polynomial, we're going to try to factor by grouping. So when they tell you to factor by grouping, you probably have an even number of terms in your polynomial. Any even-numbered polynomial, 4 or larger, you can try the factoring by grouping thing, okay? So what we will do is we're going to, because we're only going to work with 4-term ones though, we're going to make 2 groups of 2 terms each. So there'll be, we have 4 terms, divide them into 2 groups, so kind of like separate them into 2 separate polynomials. It'll look like an addition of polynomials. And then we're going to take each of those groups and we're going to GCF each group or each binomial that we'll have, just like we did for today. We will GCF each group. And then each group, the goal is, if it is factorable by grouping, that each group should have a common factor. So you GCF each group, they're working independent of each other. But then after you have GCF them, you have factored each of those groups. One of those factors in each group should look exactly alike. They should have a common factor, which actually then becomes the G. Then we kind of like bring it back together and say, okay, now we're back to treating you as a 4-term polynomial, and this is your GCF. Okay? So here's an example. Here's the 4-term polynomial to start with. We have 6x to the 4th minus 4x cubed plus 12x minus 8. Change, now today, I didn't recommend this yesterday, but now if we have a 4-term polynomial, we're factoring by grouping, change that subtraction to add the opposite, okay? So we're in one step here. They have changed the subtraction right here and here. They've changed that to add the opposite, and then put parentheses around to make the 2 groups. So that's what happened in that step. In the next step, without showing all that work we showed yesterday, are you ready to GCF without showing all that dividing? Can you do that in your head? If you can't, what you need to do is kind of like walk to the side and do it. So what has been done in this next step is say, what is the GCF of just these 2 terms, 6x to the 4th and negative 4x cubed? So you just look at the number parts first and you say, what's the greatest common factor of 6 and 4? We're going to worry about the negative right now. And that is 2. And then you look at the variable parts, x to the 4th and x to the 3rd, and you say, what's the largest number of x's I can divide out of both terms? And that's x to the 3rd. So that became the GCF of that first group. So 6x to the 4th divided by 2x cubed. 6 divided by 2 is 3. X to the 4th divided by x to the 3rd is x. So that's our division, just doing it mentally. And then we look over the next one and we say negative 4 divided by 2 is negative 2. X cubed divided by x cubed is 1. And negative 2 times 1 is negative 2 still, right? Okay. And then we move to the next group. Remember, each group works independent of each other right now. So we move to the next group and we say, okay, we got a 12x and a negative 8. So we look at the number parts and say, what's the largest factor we can factor out of both 12 and 8? Is it 2? It's 4, isn't it? So 4, and then we look at them and we say there's an x in the first term, but there's not an x in the second term, so can we take any variable parts out? So our GCF doesn't have a variable part, it's just 4. Sometimes the GCF can just be a variable or it can just be a constant. And then we take each of these and divide. 12x divided by 4 is 3x. Negative 8 divided by 4 is negative 2. Now, this is when it gets tricky. This is when students have the hardest time understanding. What did we just do? Well, we're looking for the GCF of the whole 4-term polynomial. That's really what we're doing. And what is that GCF? This one right here, the one they have in common, the one that can be divided out of both of them. So remember, whatever they have in common, that can be, remember our circling yesterday? The things they had in common? What we're really saying is this could be circled in each of them, in each of the lists, and this would be their GCF. So here's our GCF. That's one of our factors, and the other factor is what's the result after you divide that out. So if you divide it out of this first term, you have 2x cubed left. Bring your plus sign down, and when you take the 3x plus negative 2 and divide it out of this one, you have just the 4 left. So what's out here, the resulting term, the resulting binomial I need is 2x to the third plus 4. So what should happen if we FOIL that back out? What would happen if I told you right now to FOIL 3x minus 2 times 2x cubed plus 4? You did the first expression. It's not really an equation because it doesn't have an equal sign, right? You better get back to that right there, what we started with. I mean, today you do have to do check problems, and you have to check to see that you do get back. You do have to multiply. Okay, let's practice together here. We have this first one. 6a to the third plus 8a squared plus 9a plus 12. Make groups. In the process of making groups, change any subtraction to add the opposite. Or in other words, maybe I should say it this way. Change any subtraction to add the opposite, and then insert your parentheses. Well, we don't have any subtraction, so we can just insert our parentheses right away. And make our groups. And now we will GCF each group. So 6a cubed plus 8a squared. First thing we're going to look at is what is the largest number that can be divided out of both 6 and 8? 2, right? Okay, so we put a 2 out here. What's the most number of a's that can be divided out of a cubed and a squared? A squared, right? You have 2 of them. Okay? So there's our GCF of that group. 2a squared can be divided out of both terms. What is 6 divided by 2? 3. A cubed divided by a squared? A. So for those of you who need this maybe in your notes, what we're doing is we're taking this right here and dividing by our GCF. Just like we did yesterday, we're dividing by our GCF. We're just not showing the work. We're doing it up here today, if we can. But if we can't, we probably should do that. So 6a cubed divided by 2a squared, we just said is 3a. Plus, what's 8a squared divided by 2a squared? 4. 8 divided by 2 is 4. A squared divided by a squared is 1. 4 times 1 is 4. Okay. Anybody got questions about that group? Okay, why don't you try and GCF the next group then? Right. What's going to happen in the next group? What is the GCF of the second group? 3. After we divide that GCF out, we should get 3a plus 4. Because we actually do, right? So in other words, again, we're taking the 9a, dividing it by the 3. We're taking the 12 and dividing it by the 3. 3a plus 4. At that point, we should feel pretty good because we have that common factor right there. So what is that again? What do we consider that to be? The greatest common factor of the whole thing. We just found the greatest common factor of our beginning polynomial. So we have 3a plus 4, and we have to put it in parentheses today because it's not a monomial. Yesterday, the GCS we got out in monomials. Today, they're binomials. And then we say to ourselves, what would the resulting factor be? What would we have after we divide that GCF out of both terms here? We really have it down to 2 terms there. So what's the next factor going to be? The other factor. Who wants to be brave and think they can tell us what it is? Jared?
2a squared plus 3.
Yeah, it's 2a squared plus 3. When we divide the 3a plus 4 out of this first term, this is what we get. When we divide the 3a plus 4 out of this term, this is what we get. So, in reality, we're just still dividing, and maybe I need to just put it here for some of you to see. This is a kind of a challenging concept to grasp. We're really just dividing. That's the first part of it. That's that one. And the other one is our 3 times 3a plus 4. And that's being divided by 3a plus 4, our GCF. So notice what happened. These cancel, and we have 2a squared. These cancel, and we have 2. So this is our final answer right here. This is our, maybe you should put this. This is our answer. 3a plus 4, that binomial, times the binomial 2a squared plus 3. Now I want you to FOIL that back out, rectangle it, vertical multiply it, whatever you do when you multiply binomials. So what you're going to do is you're going to take our answer, you're doing a check problem today. You did them yesterday, I didn't require them, but that's awesome. Multiply that out. FOIL, rectangle, your method. Mine to multiply that up to that's like your theory blending. You multiply that up and see how you do it. And we'll do that for a factor of 1 thing, and then multiply that into what we started with, which is a lot. Okay, so I use FOIL. Some of you prefer rectangle. We need to talk about any parts of that. This is one where it was straight addition all the way across to begin with. This is the easiest one. They're the ones that students have the least amount of trouble with. So we're only going to practice one of that kind. Okay, then let's look back and let's practice one that doesn't have just addition all the way across. Okay, now again, when we're going to do factoring by grouping, we are going to change all subtraction to add the opposite. So that's our first move. 2x cubed plus negative 6x squared plus 9 plus negative 3x. And notice I didn't put any parentheses in yet. All I did was change it from subtraction to add the opposite where we were needed. After you have 3 additions, then you're ready to put your groups together. But not before. Okay, now we have our groups. Now we need to do what? What's our next step? GCF each group. They're working independent of each other. They're each going to get their own GCF right now. Okay, so what are we going to say is our GCF for our first group? 2x squared. So 2 is the largest number that can be divided out of both 2 and 6. X squared is the largest variable part that can be divided out of both of them. And then you say, okay, let's do the division. If I have 2x cubed divided by 2x squared, what's the result? X. If I have negative 6x squared divided by 2x squared, what's the result? Negative 3. Move on to the other group. It's, right now, it doesn't care about that other group. It's its own group. What do we think the GCF of the next group is? 3. 9 doesn't have any x's with it, so we're not going to be able to take any x's out at all. So, what's 9 divided by 3? What do we get? 3. What do we get if we take negative 3x divided by 3? Negative 1x. Did we get a common factor? What are we going to do when we don't have a common factor? Can anybody see something that, if we just change one little thing, it would make those, a couple of those things match? What do you think, Gabby?
The x plus negative 3 and 3 plus cancel.
They are the same, you're saying then?
They're opposites.
They're opposites, well, but they're multipliers, so when they're multipliers, we can't do any canceling. Now, if there was all straight addition going on here, in other words, if there was addition in between here and here, then we could say, oh, those guys are going to cancel each other out, but we're not adding. So we can't do that, sorry. But it was a good thought. Okay, I got to get those addition signs out of there. Okay. Jacob?
Associative property.
Associative property.
It's, for the second one, it would just be negative and x plus 3.
Okay, so you're saying they could trade places. Commutative property, that is.
Oh, weird.
Commutative property. Okay, so you're saying then that, I guess I need a pen back. You're saying that we could rewrite this. This could be x plus a negative 3, and this one could be rewritten as negative x plus 3. Okay, do they still match? Yet? Have we got them to match yet? No? Elena? Take one of them times a negative 1. Oh. Well, if we took one of them times a negative 1, we would have to make sure we did that to everything. So, could we instead of dividing out a 3, could we make that a negative 3, do you think? Could we divide out a negative 3 instead of a positive 3? Does that matter, or to divide? So what's 9 divided by negative 3? What's 9 divided by negative 3? Negative 3? What's negative 3x divided by negative 3? 1. Where's my eraser? So instead of dividing by a positive 3, our GCF of the second group being a positive 3, we're going to have it be a negative 3. That's okay. It doesn't have to be a positive number. So let's just double check and make sure we haven't done anything we can't do. In other words, let's just take a moment and multiply this back out in our heads and make sure it matches what we had up here. Okay, so negative 3 times x. Negative 3x, isn't that what we have up here, right there? Negative 3 times negative 3. 9, isn't that what we have right there? We're just renaming that. Okay, so we're all right, we're cool? So now we have our common factor. They have to look exactly alike. It's being multiplied in the first one, it's a multiplier in the first one, it's a multiplier in the second one. So now that is our GCF of the whole original polynomial. And the other factor is what?
X squared plus negative
2x squared plus negative 3. In other words, these right here. Now let's clean that up. Oh, wait a minute. We have to check it anyway, but when you check it, we'll use this form. But let's clean it up for the answer bank. What would this be cleaned up?
3. X minus 3.
X minus 3,
2x squared minus
2x squared minus 3. There's its factor form cleaned up the way we would see it in an answer bank. And by the way, it doesn't matter which of those factors is first, which binomial is first. Multiplication allows them to trade places, so if 2x squared minus 3 says move over x minus 3, I want to be in front. It can be. Okay, now I want you to do a check problem. I want you to multiply that out and see how we did. So I want you to take this binomial times binomial and multiply it out. You might want to go back to add the opposite thing. Because you have to do the check problems in your homework. If this is your stamp your paper tomorrow without check problems, I'm just taking the stamp back away again. So, not only do you factor, but you check. Foil, rectangle, whichever way you want to do it. Some of you are like waiting for me to do it for you or something. I'm not going to. I'm going to do it myself. It didn't end up in the same order as it was up in the problem. Can you still compare them? So, in other words, can the x squared and the 9 move over and trade places? So we would have 2x cubed plus negative 6x squared plus 9 plus negative 3x. That's, they had the cubes versus the squares, then they had the constant, then they had the x, and then clean it up and see if it looks exactly like it when it's cleaned up. Now, here's what happens. I'm just going to caution you not everybody know this trick, because I know there's some people who want to, do it to get it done. Here's what students do when they're doing the check problem and the multiplying. They write out the steps, but then they look up above and they say, well, this is what it's supposed to get. And the craziest thing is, sometimes down here, you notice how these ended up out of order? The craziest thing is they get some products down here that don't make any sense because they're trying to shortcut it and pretend that they were actually checking it. So, when you're doing this check problem, you're back in chapter 6 when you didn't know how to do that. You're back in chapter 6 multiplying. You only knew how to multiply then, you didn't know how to factor. So when you're down here doing the check problem, revert back to chapter 6 and say, I'm not in chapter 7 right now. Okay, anybody get concerns about that one? Sometimes it's hard to know what to ask because it's just enough to just figure out how to do it while we're doing it in class. Okay, what's the first thing we're going to do in this one? Add the opposite. Okay. Now, what do we do? Now we can put our groups together. So we'll go like that. Okay. Now what? Greatest common factor of what? The two groups, they each have their own, don't they? So go ahead, why don't you try this one? See if you can GCF each group independent of each other. Do that step. What's the goal of this step? To know if things went wrong. What's the goal? When you're done GCF each group, what better be true? They have to have a factor the same. They have to have a binomial factor that is the same. So in other words, the monomial parts aren't going to be the same necessarily. But the binomial parts, so this is just what we were doing yesterday. When we were factoring binomials yesterday, that's what each of our groups are, they're binomials. When we were factoring binomials yesterday, we had a monomial factor and a binomial factor, right? So that's what happens in each group. We end up with a monomial times a binomial. What should hold true is if you were successful, if things went well, or if you're ready to move on, you can say to yourself, do my binomial factors match? If they match, you're ready to move on. If they don't match, you might have to reevaluate like we did on that last problem and say, I'm not going to divide out a -3, I'm going to divide our +3, I'll divide out a -3. So it's kind of like you become a manipulator. Okay, so what's our GCF of this one? Y² plus -2, that binomial factor they have in common. After we divide that GCF out of our two-term polynomial as it is right now, one term, two terms, after we divide that out, bring our plus sign down, we have a Y, oh, we don't bring our plus sign down, what am I doing? Where did that come from? We have another factor here, we bring our Y down, and there's where we bring our plus sign down, and we bring our 4 down. And now we do check bottom. Go ahead and multiply out. Foil, rectangle, horizontal, vertical. And for those of you who don't like to show recidities, you have to for this multiplying, because otherwise it's just going to look like you just got what you were supposed to get and you didn't really verify it. Rectangle method this time. Okay, I finally got it to the way it was supposed to. In other words, I actually legitimately multiplied, didn't care what was up there, got this, and And then I looked up there and said, okay, the y cubes are first, and then are the y's, and then is the constant, and then are the squares. And then I cleaned it up, and then I went and said, okay, does it look exactly like it's Okay, and you're ready to work. Now, Jacob?
For number 2,
Okay, back to the second one. Okay.
when we change 3 to negative, how do we do that?
Okay, when we were GCFing, we just said basically what, because we looked at both of them and we said the largest number you can divide out of 9 and -3 is 3. We can also divide out the opposite of a constant too. So what we did is we said, how about if we divide out a -3? Because if we divide 9 by a -3 and a -3x by a -3, we like the results better. We get a -3 plus a positive x, and that's the other one looks like. So here's what I suggest you try. If you divide out a GCF, and typically you're going to always divide out a positive one. Okay? If you divide out a positive GCF, and the factors look like they're close to matching, but they just need to be the opposites, then change your GCF to be negative. Okay, that makes sense? Okay. It is that those are the toughest ones. They can be most challenging.